Okay. A question was asked about where do you put the electrons in when you're writing an orbital picture. And so let me kind of give you a quick kind of refresher on that. So let's say that, for instance, I have the molecule that I talked about today in lecture, and we'll look at one of the resonance structures here. So when you're going to draw an orbital picture, the first thing that you have to do is you have to identify the hybridizations of the different atoms, and the non-hydrogen atoms in this case. And so the number of hybrid orbitals is equal to the number of single bonds, which are also the sigma bonds, plus the number of lone pairs. So for carbon, it's just the number of single bonds, because carbon doesn't always have lone pairs. It's very rare that it does. But for nitrogen and oxygen, they always have lone pairs. And the number of hybrid orbitals then is going to give you that hybridization. So for instance, if I looked at this carbon right here, that carbon has 4 sigma bonds, 4 single bonds. And so therefore it has 4 hybrid orbitals. Well, if it has 4 hybrid orbitals, then that means it has to be sp3, because that's how we have 4 hybrid orbitals. That's how we combine. So that carbon then would be sp3 hybridized. And so what we would do then is we would write the sp3 hybrid orbitals, 4 of them around that carbon. Well, 3 of them are overlapping with the hydrogens. And I guess I should go back and say each one of those hybrid orbitals has 1 electron each, because carbon has a Lewis dot structure of 4 unpaired electrons. So then looking at the second CH2 carbon, it is also sp3. How do I know that? Because it's got 4 hybrid orbitals as well, 4 single bonds. And so that means the carbon would have 1, 2, 3, 4 in this tetrahedron. Each one of those hybrid orbitals having an unpaired electron, 2 of them overlapping with the 1s orbital of hydrogen. So then looking at this nitrogen, the next question is, well, what is that nitrogen's hybridization? Well, it has 2 single bonds, 2 sigma bonds, and 1 lone pair, which means it has 3 hybrid orbitals. Well, how do we get 3 hybrid orbitals? An sp2. So that means that nitrogen then is sp2 hybridized. So I would write that nitrogen having 1, 2, 3. These are my 3 sp2 hybrid orbitals, and I like to shade them. And then it's got 1 unhybridized p orbital. Okay. And let me come back and explain where we're going to put the electrons. But let's look at the next nitrogen. So the next nitrogen is the same. It's got 2 single bonds and a lone pair, which means that nitrogen is also sp2 hybridized. So let's say I'm going to overlap this. Here are my 3 hybrid orbitals, and they are trigonal planar, along then with the unhybridized p. And so that makes that nitrogen sp2. Then how about this final oxygen? This final oxygen has 1 single bond and 3 lone pairs. That means it has 4 hybrid orbitals, which means that it is sp3 hybridized. And so if I wanted to, I could have, here's my oxygen, which is also then sp3 hybridized. So this nitrogen was sp2, and this nitrogen was also sp2, and then the carbon was sp3. So again, you take the number of single bonds plus the lone pairs gives you the number of hybrid orbitals. And then if you have one hybrid orbital, which you can't have, so we need two hybrid orbitals, is sp. 3 hybrid orbitals is sp2. 4 hybrid orbitals is sp3. And then we'll get to 5 and 6 in a subsequent lecture. So now the question is, well, what do you do with the lone pairs? Now, carbon had one unpaired electron per orbital because this is the Lewis dot structure for carbon. What's the Lewis dot structure for nitrogen? 3 unpaired electrons and the lone pair. Now, you cannot place a lone pair into the p orbital. So the p orbital can only have unpaired electrons. And that means that the hybrid orbitals are where the lone pair go. So if you have a lone pair, it has to go into the hybrid orbital. So that means for this nitrogen, it's going to have one of its unpaired electrons in the p orbital. And we always form these head-to-head overlaps of sigma bonds by one unpaired electron in that sp2 hybrid orbital overlapping with another hybrid orbital. So that means for this nitrogen, the three of the lone pairs, or 3 of the unpaired electrons go, 2 go in the sp2 hybrid orbital, 1 in the p orbital because that's where it has to go, which leaves the lone pair in the hybrid orbital that's to the outside. So that basically that's this lone pair. So for the other nitrogen, we again have 3 unpaired electrons in a lone pair. The unpaired electron has to go in the p orbital. It has to be used, the other unpaired electrons have to be used to form the single bonds, which leaves the lone pair going in that hybrid orbital. And then for oxygen, it has, in this case, 1 unpaired electron, because that's being used to form the single bond, and 3 lone pairs, so that means this unpaired electron will pair up with this one, and then the unpaired electrons then go into the 3 hybrid orbitals. So where did the electrons go? Number 1, they always go into hybrid orbitals. And you have to kind of draw out, first you got to determine the hybridization of each atom, and then sketch out the picture of that atom. All sp3 atoms look the same. All sp3 hybrid atoms have 4 tetrahedral lobes. Any sp2 atom has a p, and then 3 sp2s. And then finally the sp3 or the sp atom, any sp atom is always going to have, I should make it a carbon, I'll make it any atom, because it doesn't matter what the atom is, it's the hybridization. It will have 2 hybrid sp orbitals, and then it will have 2 unhybridized p orbitals. The lone pairs always go in the hybrid orbitals, and if you kind of draw out the Lewis dot structure, you can kind of see that those lone pairs are going kind of where they would from this Lewis dot structure. So then in terms of finishing this picture up, overlap, head-to-head overlap, sigma bond, overlap, head-to-head sigma bond, overlap, head-to-head sigma bond, overlap, head-to-head sigma bond. The only thing left is the sideways overlap, the 1 electrons in the p orbitals, that would form the pi. So again, this is your pi bond, and then everything else is a sigma bond. including the carbon-hydrogen sigma bonds. So that's where we put the lone pairs of electrons around an atom. We have to first of all identify the hybridization by using this formula, then sketch out the hybridization of that atom, figure out what that atom is in terms of what its lone pair, how many lone pairs and unpaired electrons it has, and then you distribute those into the orbitals where the unpaired electrons have to go in the p's, but the unpaired electron could also go in the hybrid orbitals. The unpaired electrons are going to go in the hybrid orbitals that are going to overlap head to head to form the sigma bonds. So that's kind of how we would put the pairs of electrons into that type of a molecule. Okay, so hopefully that makes sense. If it doesn't, follow up on Piazza or follow up in class.